Hey everyone, it's Mr. Hayden here, and today we're going to learn about piecewise functions, which you may have learned in Algebra 1 or integrated algebra. But piecewise functions are how the income tax code is computed. So we're going to do a little section on income taxes, and they are based on a piecewise linear function. So piecewise function, it's sort of like a multiple choice function where you have a different line for different portions of the xy plane depending on what the value of x is. So when x is in one range, you use one rule or one equation. When x is in another range, you use another equation. There could be two, there could be three, four, as many as you want. And actually, if you look over here, you'll see that this is the piecewise function for the tax bracket from a couple years ago. And there were 6 different equations. And then after you see the equation listed, it'll give you the constraint or the condition that tells you what region or what values of x is that equation applicable. Typically, these cover the entire x-axis as you go from left to right, but it's possible there may be a hole in the middle of the piecewise function, and in a certain range, the function may be undefined. So for example, for the income tax code, the function's really undefined when x is less than 0 because you don't pay income taxes on negative income, and the federal government doesn't give you interest on negative income, which would essentially be the government owing you money because you made less than 0. That doesn't happen, so the restrictions and constraints on x for the income tax code is x being greater than or equal to 0. Okay, so a different rule is used to evaluate each piecewise function, and each equation is what's called the rule of the function or the relationship or the pairing. Okay, so how do you evaluate a piecewise function? Well, evaluating a function means substituting a value in for the variable and simplifying. So with a piecewise function, you have to check to see what range the value is and use the applicable rule for when x is within that range. So for example, f of 5 for this function above, well, is x less than 1? 5? No, 5 is greater than or equal to 1. So you would use the lower rule or the lower equation to evaluate, and you would get 4 times 5 is 20 minus 2. This would be 18. Okay, f of negative 2, well, negative 2 is less than 1, so we would do negative 2. 2 times negative 2 is negative 4, minus 3 would give you negative 7. 0 is less than 1, so I would do 0 minus 3 would give you minus 3. And then 1, when you put 1 in there, I would get 2 minus 3. Well, actually, is 1 less than 1, or is it greater than or equal to 1? It's greater than or equal to 1. So I would use the 4x minus 2 rule. So that would give me 4 times 1 minus 2. That would give me a 2. And you have to forgive me, I'm writing with my mouse cursor, so I'll do the best that I can. Okay, so I just went over that income taxes are based on a piecewise function. The reason it's based on a piecewise function is that the more you make, the higher your income, the greater the percentage of your income you pay in taxes. And this is meant to benefit the poor, because if you think about it, people who have very little income, they really need all of their money just for the basic necessities of life, whereas people who are very affluent, you know, everything is pretty much icing on the cake beyond a certain amount of income, and they're not going to suffer too much if they're paying a little more in income taxes, whereas the poor will really suffer if you raise the income taxes. And this is why a lot of very left-leaning Democrats have picked up the call to tax the rich, because it would enable the government to possibly lower taxes on the poor and middle class. Okay, so how do you graph a piecewise function? Well, you look and see what the range of x is, ranges for x are, and then at each boundary value, and when I say a boundary value, I mean the number that is part of the inequality that determines what range of x you're talking about. You kind of visualize an imaginary dotted line going up and down, and then on the side of that line where one of the rules is defined, you graph the one line, and on the other side you graph the other line. So for this one, oh, and you need to make sure that when the constraint says less than or greater than, you put an empty circle right on the boundary line, and then when it says less than or equal to or greater than or equal to, you put a solid dot. Okay, so I'm going to do, and I'll just put kind of an imaginary dotted line here. Hopefully it will. Let's see if I can do it. Okay, so my boundary line is kind of right here, around here at x equals -2. One second. So I'm going to, surely I can do a better job than that. Let me see if I can do a better job than that. All right. So let's actually start there. That's going to be much better. Okay. To the left, I'm going to graph 3x plus 1, y equals 3x plus 1. So y equals 3x plus 1 is going to go through 1 on the y-axis, that's the b value, and go up by 3 and then over by 1. All right, so now that's applicable all the way from this boundary line all the way down to the left, because that's when x is less than 2. Then the other one is 2x minus 1 when x is greater than 2. So I need to go to -1, and then I'm going to go up 2 over 1, up 2 over 1. Okay, so here I'm going to start, and I go up 2 over 1, up 2 over 1, up 2 over 1, and then up 2 over 1. All right, now I need to decide right at the boundary line, do I put solid dots or empty circles? Well, for x less than 2, which is this one, I'm going to put an empty circle. And then this one is x is greater than 2, and I'm going to put a solid dot if I can manage to draw it. There we go. Okay, so this is typical of what you'll see for a piecewise function. You'll see something that's kind of disjointed and looks kind of funky. It looks like different line segments that kind of are defined in different regions. So I'm just going to do one, well, let me do one more. Well, actually, I'll do a few more. Okay, so here we have the boundary line is x less than 1 and x greater than or equal to 1. So that's going to go right there. And then I'm going to do -2x plus 2 when x is less than 1. So a -2x is going to be down 2 over 1 starting at 2. So it's going to go like that. But now I need to make it go all the way up to the boundary line. All right. And then y equals 4 when x is greater than or equal to 1. So that's a horizontal line that goes straight across like that. All right. Now, it just turns out that both of these lines intersect at 1, 4. No, you know what? I'm wrong. I did positive 2x. We're talking negative 2x. Okay, negative 2x plus 2 is going to be, start here, and it's going to be down 2 and over 1. All right, and then it's going to continue on up through there. All right, and then when x is less than 1, so that would get the empty circle on the boundary, and then x is greater than or equal to 4, we're going to have a solid dot that's right there. Okay, so that would be that one, and now let's do this one. Okay, so this one has 3 rules. So, and the boundary lines are gonna be kind of right at -5 and 1. All right, so now I'm going to graph 3x when x is less than -5. Okay, so x is less than -5 is way over here, and 3x has a slope of 3, and it goes through 0. It has a b value of 0. So a slope of 3 is up 3 over 1, or down 3 to the left 1. Down 3 to the left 1. Down 3 to the left 1. Down 3 to the left 1, and then down 3 to the left 1. So it's going to go way down there. All right, and then x less than 5, it's going to be like that. Okay, then in the middle, I have -3x. So -3x also goes through 0. It has a b value of 0, and it's down 3 to the right 1 for a slope of -3, and it's going to do something like that. And then we're going to get a solid dot on this side because that's the less than or equal to negative in between, or -5, and then also a solid dot on the other side because we have a less than or equal to symbol. And then finally, when x is greater than 1, we have a slope of 3 again. So that has a b value of 0. So we would start at 0, we'd go up 3 over 1, and then up 3 over 1, like that. And then I'm going to have an empty circle, just like that. Okay, so obviously not the best example because I picked bad equations since this one is so far off the graph, but so be it. That's what I happen to pick for some reason. Okay, then the next one is kind of a unique piecewise function. It's called a step function because it looks like steps as you go from left to right. So my boundary lines are at -2 and +2. So -2 is right there, +2 is right there, and this one should be a little bit easier to graph. When x is less than -2, my equation is y equals 1. So that's a horizontal line that goes through 1. And I'm going to put a solid dot at the boundary line because it's less than, not less than or equal to. Then I have y equals 3 when x is in between -2 and 2. Okay, so that means I'm going to go like that, and I'm going to put 2 solid dots. All right, and then lastly, y equals 5 when x is greater than 2. So I'm going to go across here like that, and it's going to be an empty circle. Okay. All right, so I'm just going to pause for a second. I hear some commotion going on in the background. I'm going to have to break up a fight of 4-year-olds. So just give me 1 second here. I'm just going to pause. All right, so now I'm going to show you how to graph these in Desmos, how to do a piecewise function in Desmos. It's actually pretty convenient to graph these in Desmos instead of by hand. So because then you don't have to do all the drawing of all the lines yourself, and you don't have to worry about making straight lines and doing rise and run and so on. So the way you graph a piecewise function in Desmos is, first of all, you say y equals, and then you put an open curly brace, sort of like the curly brace here, And then the next thing you do, instead of writing the equation part first, you write the constraint part first. So if I'm doing this one right here, I'm going to do x less than 1, and then you put a colon, dot, dot, and then you put the equation, so negative 2x plus 2. All right, then I'm going to do a comma, and then the next constraint is x is greater than or equal to 1, and in that case I put a colon, and then I would put a 4. So there you go. That's how you would graph it. It pretty much looks exactly like what our graph does there. Okay, so now let's try this one. So I'm going to put y equals, open curly brace, and then I put the first constraint, x less than negative 5, a colon, dot, dot, then 3x. All right, then I put a comma, and then now for x being in between negative 5 and 1, I put negative 5 less than equal to x, then less than equal to 1, then I put a colon, and then my equation, negative 3x. All right, then I put another comma because I have another rule, and then I'm going to say x greater than 1, colon 3x. All right, and now let me get rid of the first one so that you can see. And let's see, is that what ours looked like? Yes, indeed it is. Let's see. Okay, and now let me just do maybe one more for good measure. I'll do the first one that was on the front page of the notes. So let's go back to Desmos, and this one is going to be y equals, and then open curly brace, and then I put x less than 2, dot, dot, 3x plus 1, and then I put a comma, and then x greater than equal to 2, I put a colon, 2x minus 1, and there we go. So there you have it. That's how to graph piecewise functions. I'm not going to make you do the graphing on paper now that we've graphed lines, and I think it's more valuable at this point that you really are extremely familiar with Desmos when you go to college. So we're just going to have you do your homework on Desmos. You can still do it on paper if you want, but I think it will be much easier in Desmos. Now, when you do homework in Desmos, I think I've kind of said this in the last assignment, I want you to put a note above the equation that you're graphing that says what problem your equation is. The way you do a note is where you would ordinarily write an equation, you type a quotation mark, and then you can just say something like this, problem number 1. And then right underneath it, you would put the equation for problem number 1. Then, do the same thing for, let's say, problem number 3. And then you put the equation right under it. All right. And then if you could try to name your graphs or projects, give it like the same title as what the notes and homework is. In this case, it would be piecewise function. So you would just do like piecewise functions and then homework. And I guess piecewise is not recognized in the dictionary. Okay, so I would just do that. And then lastly, of course, you share it to me. So copy the link, and then really the easiest thing to do is submit the link in Google Classroom. That way we have it in one place and I don't have to like go scanning through my entire email for your homework. So that would be great if you could do it that way. So, so the homework for Monday then is going to be the piecewise function homework that's in the document, the homework document that I'm posting in Classroom, and you should do it in Desmos the way I have just done it here. All right.